Welcome to the lecture on defect diagnosis in castings. So, we have so far studied about different type of molding methods, castings of different types of metals and alloys. We also discussed about the different kinds of defects which arise due to variation in parameters because of many kind of effects, like it may be because of the molding material, it may be because of the gases, it may be because of metallurgical characteristics and so on. The ultimate aim for any foundry is to make the defect free casting and also to ensure at the end that the product which is coming out is defect free. So, there are two ways of checking whether the casting is having defect. One is destructive method and another is non-destructive method. So, destructive methods are used for finding the tensile strength or hardness or so, but when we go for destructive methods, the casting will no longer be further used. So, in fact, there are non-destructive testing methods which basically see and check whether casting is having any defect or it is defect free. So, for critical components, especially if there is any crack in the inside of the casting or if there is any kind of imperfection which cannot otherwise be seen, in that cases the non-destructive testing methods are adopted. Now, so non-destructive testing methods are used to carry out the or to check the soundness of the casting, control of microstructure in certain cases and so on, like coating thickness or so. So, there are many ways of doing this non-destructive testing, and these methods are like visual methods, where you just see through the naked eye and see whether there is any discontinuity present in the casting. So, based on that, if there is any warpage or if there is any discontinuity, any crack, any poor surface finish, those things can be checked using the visual methods. Certain methods are used for the surface defects, like the magnetic or penetrant type of defects, which are used for checking the surface flaws. So, if on the surface there is any kind of defect, then these methods can be used to find the defect. Then you have radiography test or fluoroscopy test or ultrasonic test, eddy current test or pressure testing. These things are used basically for the internal kind of defects, and we will discuss one by one about the different kinds of these methods and know what is the procedure for knowing whether the casting is defect free or having any defect. So, we will go one by one. So, visual anyway, visual means by looking with the naked eye or with the eye, if you see that it is okay, it is fine. Next is the magnetic particle test. So, it is basically applied for ferrous components which are basically ferromagnetic. So, what is done is the magnetic field is induced in these materials, and so a field will be generated, and then if there is any discontinuity, then that cuts the magnetic field and that creates the flux leakage. So, that can be seen. So, suppose you have a casting, and if you induce the magnetic field, you see these field lines, and in the case of any kind of crack here, you can see there is a crack. So, in that case there will not be continuity in these magnetic field lines. So, what you see is they try to pass from this side to that side, and there will be, you can see so what we do is normally we apply the fine finely divided powders, magnetic powders on the casting surface that may be dry or that may be basically in a solvent, and then once you apply, then you apply the magnetic field. So, basically whenever there is any discontinuity, then there will be changes because of the flux leakage, there will be change in the pattern, and at those points you will see that these flux lines have to pass. So, there is heap of these powders at this point because there is no continuity because of these cracks. So, as it moves, you can see a visible difference in the powder which is here, and this way you can say that there is some discontinuity or especially crack which is there at this point. So, for maximum sensitivity, normally the surface discontinuity must cut the magnetic flux at right angles. So, if the magnetic flux lines, if they are in the line of this cut or crack, then you cannot easily distinguish, but if they are at the right angles, then you can very much see, and that is more visibly clear when these discontinuities are cutting this magnetic flux at right angles. So, that is how you can basically visualize these cracks and use these magnetic particle test. So, normally the limitation is that it is only used for a specimen or for a casting material which is ferromagnetic, which can be magnetized. Then next is the dye penetrant test. So, this is penetrant test based on the name that something penetrates into the cracks. So, this can be used for ferrous or non-ferrous materials. Here there is no such limitation on what kind of material it can be applied. So, here we can use dye or that is basically a liquid is there which is containing a dye, or you may have a fluorescent penetrant. So, it basically depends upon what kind of light you are exposing later on, so that you have a contrast and that is seen. So, we will discuss it. So, what is done is you apply this dye over this surface. So, suppose you have a crack, you apply this dye on this surface. So, because of its low surface tension and viscosity, this dye is seeped into this crack. So, once it goes into the crack and you ensure that this dye is basically applied fully on the surface, then you wipe it off later on. So, in this stage it is completely wiped off or cleaned. Then what you do is further you are so here it is basically with dirt. So, first of all the first stage is that you clean it and then you apply this penetrant, and then you remove this penetrant from the surface, but the penetrant which has gone into this crack still remains here. So, this with the red color you can see that this penetrant is still there in here, but from the surface you are basically thoroughly cleaning it, and as we discussed, because of very low value of surface tension and viscosity, the penetrant goes into this crack. Then what you do is you apply a developer. So, what developer does? This developer basically goes here and that basically has a blotting action. So, that basically soaks away this dye which is there inside, and then it comes over the surface. So, when you see under the visible light, this looks red. So, this way once if there is no crack, there will be no dye which is into any crack. So, you will not see any such color, but if the crack is there and if dye has penetrated into it, then this developer which has the blotting action that basically takes these dye which is into the crack, and then it, when you see under the visible light, it appears as red. So, if it appears as red, you assume that there is some crack because it had gone into the crack. Similarly, if you see that under the ultraviolet light, you will see the color as greenish yellow. So, depending upon what kind of light you use, whether it is visible light or the ultraviolet light, this color changes, and you can see that you can detect these cracks by using these penetrant test for ferrous or non-ferrous materials. Next is radiographic testing. So, radiographic testing, they use the kind of rays, and these rays are penetrating ionizing radiations which are passed through the component. So, these rays are normally used for ferrous or non-ferrous components, and they are used to find the internal flaws, internal cracks. So, what is done is you have different kind of, you can use either the X-ray or the gamma ray, and then these radiations are basically passed through the component which is to be tested. So, they go and basically on any radiograph or any plate, so fluorescent plate, so sheet, you get the image. So, two dimensional image is formed, and basically that penetrates completely, but if there is any kind of defect, any kind of crack is there inside, then its shadow is being created on that sheet. So, once you see that sheet or radiograph, then you can find this here. So, as you see, if there is no defect in those cases, so this is the cast component, if there is no defect, you see that it is all clean, but if there is any defect here, it has not been able to pass. So, its shadow will be the dark one, and that shows any kind of discontinuity which is present inside the casting. So, basically it is used for finding the internal features or any defect which is internally present inside the casting. Now, you can select this ionizing radiation based upon the absorption coefficient of material of the component. So, basically you may have the high energy radiation or low energy radiations, and depending upon that, the lower part will be used for materials like aluminum, and if you go for materials like steel or copper, brass or so, then you go for higher energy beams or radiations which are used to find that. So, it is one variety is the fluoroscopy. So, in that case basically the image which is produced, that basically is projected on a fluorescent screen or even attached to a TV screen. So, you can directly see this image on the screen. So, that is known as fluoroscopy. So, these methods are used for finding the internal flaws, if any, inside the casting. Next is ultrasonic testing. So, ultrasonic testing basically, it is basically based upon the penetration of these sound waves, and they basically penetrate the section, and then the echo is formed. So, based on the echo which is formed, you ensure whether there is any kind of defect or not. So, what we do is initially you apply some coupling agent, and that is grease or any proprietary agent is there. So, that is applied between the probe and the workpiece, and then this transducer is there. So, once this emits the waves, then these waves go and strike the bottom of the casting, and then they come back. So, in that case you can see that how much time it takes to go and come back. So, there will be that indication will be coming back to the machine. In case of any kind of discontinuity, the wave is not able to go further beyond that. So, in that case it will be rebounding back from there. So, that basically produces an echo. So, what you see is, had there not been any crack, you will find that this will go smooth and then from here it will be ending. But if there is any echo, any crack, so in that case because of the crack you will have this kind of crack echo. So, presence of crack echo is an indication of some kind of discontinuity which is present in between. So, that even can tell you that where this is located. So, depending upon that you can see that how it comes and from where the crack is located. So, that can be found out. So, this method is applicable to any kind of materials, ferrous or non-ferrous, and this is how you try to see the internal cracks in the material. Next is eddy current testing. Now, in the case of eddy current testing, what we do is the alternating current is passed through a coil, and this coil is when brought closer to the part which is being tested, a disturbance in the current flow is created. Now, what happens that you will have the primary coil, and similarly when it will be brought to the casting, the secondary coil is there. So, now if there is no defect, then there is no perturbance in that vicinity. However, if there is any kind of defect, then that disturbance can be seen. So, disturbance is detected as the voltage across secondary coil or perturbance of impedance of the primary coil. So, by that we can see, we can ensure that there is some kind of disturbance and there must be something, because otherwise it will be uniform, there will not be any disturbance, there will be not any change in the voltage across the secondary coil. So, this is used for detection of surface flaws, faulty metallurgical properties and dimensional inaccuracies. So, normally even in the case of SG iron, where you have the nodules, so in those cases also you can use these methods. So, what we see is, you see that when there is no defect, in those cases you see that there is no kind of any change. However, because of the crack, as it is brought closer, when if there is crack, you see that there is this change which is observed. So, from this you can say that there is some kind of disturbance or some kind of discontinuity which is present inside the casting. So, this method is used for finding the surface flaws or any faulty metallurgical properties or even dimensional inaccuracies, and this way you can ensure whether there is any defect or not. Eddy current testing is also useful for finding any kind of flaws like the magnetic properties or the electrical properties. So, that is how these points have been written, that if there is any kind of faulty metallurgical properties, so there will be variation in the eddy current pattern, that pattern in the secondary coil which we see. So, that variation will be indicative of any change in the electrical or the magnetic property of the material. So, this is how this eddy current testing is carried out, we discussed. So, you have this pattern when there is no defect, and in the case of defect you have the changes in the pattern, you will have changes in the voltage values. So, by that you can find it out. Next is the leak detection testing. So, leak detection tests are carried out under the pressurized condition to find whether there are any micropores present inside the casting. So, for that there are two kinds of tests which are available. One is bubble test. So, what is done is the casting will be immersed in the solvent like water, and then there is pressure which is applied on the component. So, under the application of pressure, if there is any micropore, any air which is entrapped in the micropores, and if they come out, they will come out as bubbles because of the insolubility of the air which is inside the bubble, and that it cannot be inside the liquid. So, it will try to come out, and the presence of the bubble indicates that there is some micropore or there is any porosity which is there inside the casting. So, even we use the soap solution also, so that on the surface you have low surface tension, and then that basically facilitates the coming of these pores through the through the surface, and then it will come into the liquid and in the form of bubble. So, this way this bubble test is carried out. We may also use the helium or hydrogen based solvents, and that basically because they have lower surface tension. So, that also is used as the pressurizing media, and in that basically facilitates the formation of bubbles, and that gives you indication of having any leak or taking the preventive measures to further see that there is no further any kind of microporosity in the next castings. The further modification or even the smaller kind of pores can be detected by the helium mass spectrometer test. So, in this case even the smaller dimension of pores can be checked into, and you can ensure that there is no pore which is there inside the casting. So, these two tests are for the finding the leak detection test, and these are carried out on the systems or on the castings which are to be used under pressure, like in the boiler plates or valves, where the material is always under the pressure. So, on those components normally we go for leak detection testing, and this ensures that there is no at all any small pore or microporosity inside the casting. So, this is the end of this lecture, and this is also the end of the whole lecture series of the principles of casting technology, where basically we discussed about different kinds of casting processes, molding processes, then you have melting units, you have production of different kinds of metals and alloys, then its defects, and further the defect diagnosis using these non-destructive testing methods. Hope you have enjoyed this course, and good luck for knowing about this course, and we will discuss more and more through the assignments and the tutorials in due course. Thank you very much.